So what we're going to look at with this problem today is how to find the slope in general of a line tangent to our function anywhere. And that's what we're going to use this a value for, is to look at that. And then we're going to find out how we can find where the slope is specific at a specific thing. So for the slope of the function on this guy, we've got the function y equals 1 over x. And so if we're going to find the slope of the curve at any point, we have to remember this guy right here. And this is your limit formula that we're going to use to find the slope. And remember, slope is just the difference between 2 points. And instead of having x's in here, we're going to have a's. So if my function is y equals 1 over x, if f of x is equal to 1 over x, then f of a is equal to 1 over a. And so then we also want then f of a plus h, which is 1 over a plus h. So these are the different formulas that we're going to use. And we're going to look at our limit. So we want the limit as h approaches 0 of f of a plus h minus f of a all over h. So this problem looks really, really nasty, but it's actually not too bad. We just need to get a common denominator on the top. So this side would need an a plus h. And this side would need an a. That gives us all over h, a minus a plus h over a times a plus h. And when you look at that and you distribute the minus sign, you end up in the very, very, very top of a minus h over a times a plus h. And then remember this guy right here. So if I divide by a fraction, I multiply by its reciprocal. So this would also be times 1 over h. So he would also be here. And if you'll notice, the a's cancel out because a minus a is 0. And the h's divide out, so that now I have negative 1 over a times a plus h. And remember that we're looking at the limit as h goes to 0. Well, I can now substitute a 0 into h, and this becomes negative 1 over a squared. Okay? So what's the slope of the curve at any point? It's this guy right here. At any point. So if the question, and that is equal to m. That's your slope. So if the question is, where does the slope equal negative 1/4? Remember, slope is m. So I'm just going to take this negative 1/4 and set it equal to negative 1 over a squared. Multiply both sides by a squared so that we can get the fraction, the variable out of the denominator. And now I have negative a squared over 4 equals negative 1. Multiply both sides by the negative 4. And so that gives me a squared equals 4. And then when we solve it for a, take the square root of both sides. You get that a is equal to plus or minus 2. Now we need to investigate just a little bit because we want the slope to be equal to negative 1/4 right here. Negative 1/4, that's important. That means that if you have a slope of negative 1/4, you're going to have a line that should look like this. And if you look at 2, negative 2, and I draw the tangent line there, does it have a slope of negative 1/4? Looks like it could. What about if I draw a line here at positive 2? Does it have a slope of negative 1/4? And again, it looks like it could. So after we investigate, we can say, hey, when a is plus or minus 2, then we can have a slope of negative 1/4. The last one is to describe the slope in different places for this particular function. And all that means is we get to pick some different a values. So we could let a equal 2, which we looked at, or we could let a equal 5, or we could let a equal negative 6. And basically all you're wanting to do on that to investigate the slope is if you're given different values of a, and remember these are all x coordinates, then if you're given all these different values, we can just plug them back into this green boxed equation to find the slopes. So I could have, when x equals 2, we saw that, that's going to be negative 1/4. What about when x equals 5? Well, that would be negative 1 over 5 squared, which is what? Or when x is equal to negative 6, then I would have negative 1 over negative 6 squared. What is that? And so these are all different ways to find slopes of those equations.